Okay, so for the function f of x that you see here, is this function, remember, in order to talk about inverse, your function must be what kind of function?
1-to-1.
1-to-1. Is this function 1-to-1?
Yes.
Yes. Why is it 1-to-1?
It's a line.
Okay, and what and the only
Linear.
linear function that's not 1-to-1 is which linear function?
Horizontal.
Horizontal. So this is not a horizontal line, so it is 1-to-1. And remember, a 1-to-1 function says that for each y coordinate, there's only what?
1x.
One x coordinate. And so if you were to graph it, and we will, but if you were to graph it, you would see that it passes what test?
The
Horizontal line test. All right. Now, we found the inverse intuitively. Just by looking at it, we found the inverse. Because right now, f of x does what to x? What does f do to the value x?
Multiplies it by 8.
Multiplies by 8 and then
Subtracts 9.
subtracts 9. The inverse does the opposite of those operations. So if the function f has the operations multiplication and subtraction, then the inverse will have what operations? Addition and division. So based on just by inspection, what you see here, what is this inverse?
9 plus 8x over...
X plus 9 divided by 8. So that's the inverse. X plus 9 divided by 8. Now, let's go ahead and graph those two functions. Now, remember, when graphing the function f, I'm going to use 3 points for f. So graph f of x and f inverse of x. Now, these are both linear functions, and to graph linear functions, you just need 2 points, but I'm going to go ahead and I'm going to go ahead and plot 3 of them. So I'm going to use a t-table. And I'm using a t-table rather than slope and intercept because I want you to see that if the point 5,4 is on f, then what point better be on the inverse?
4, 5.
If the point 4,5 is on f of x, then what point's going to be the inverse?
5,4.
5. Did I say 4,5 or 5,4? Whatever I said.
You might have said it both ways.
Interchange, right? It's not taking the opposite, so don't, I heard someone say negative.
Yeah.
Okay, you just interchange the coordinates. Okay, so if x is 0, what is the y coordinate for f of x? Negative 9. If x is 2, what's 8 times 2? 16 minus 9? 7. If x is, I don't want to use a -1 or anything like that because then this is going to be too big. So if x is 3, oh, that's going to be too big also, right? Let's use 1. If x is 1, 8 times 1 is 8. 8 minus 9 is -1. And then let's just go ahead for right now and just use -1, even though we're not going to plot it because it's going to be outside of this plane. But what's 8 times a -1? A -8 and a -9? -17. Okay, now remember the inverse takes the output that you see here and you get the input back. So the inverse will take -9 and will give you what value back? 0. The inverse will take 7 and give you what value back? 2, and so on. And it does, because look, if I go here, and remember, in place of x, I'm substituting this output here. So I'm going to substitute -9, 7, -1, -17, just to show you. And I didn't have to use those numbers to graph this line, by the way. I could use any other values for x, but I'm using those values for x just to show you that what this inverse does. So if x is negative 9, what's negative 9 plus 9? 0 divided by 8? 0, right? And so notice 0, 9 became what? I'm sorry, 0, negative 9 became negative 9, 0. So if x is 7, 7 plus 9 is 16. 16 divided by 8 is 2. I should have gotten 2, right? If x is negative 1, what had a better get on that inverse? 1. Negative 1 plus 9? 8 divided by 8? 1. All right, and then negative 17. What's negative 17 plus 9? Negative 17 plus 9? Negative 8, right? Negative 8 divided by 8? Negative 1. Okay. So I'm going to go ahead and plot these points. Okay, so first of all, let's plot the points for f. So I get 0, negative 9, which is here. I get 2, 7, which is here. Oops, sorry. 2, 7, which is here. All right, and then I'm going to draw that line. All right, so when you draw that line, you get this. All right, so this is f of x right here. All right, so that's f of x. Okay? And then g of x, I'm going to plot a few of those points. I get negative 9, 0, which is here. And I get 7, 2, which is here. All right, and if I draw a line going through those 2 points, I'm going to get this. All right. Okay. So now the worksheet I asked you to work on yesterday, some of you are turning them in. What I really want you to do, remember they're lines, right? And their slope's not the same, so they're going to intersect. So I'm going to want you, just like these intersected, I want you to draw it to where they intersect. So you need to use some rulers to do that. Don't do it by hand. You have access to rulers. So at some point today, make sure you draw the lines until they far enough to where they intersect. Okay, now inverses, these two functions are inverse of each other, correct? Inverses are symmetrical. They're symmetrical about the line. Now remember when we talked about in part 1, we talked about the fact that x became y and y became x. All right. So basically you're saying x is equal to what? Y, and y is equal to what? X. So if we look at the line y equals x then, because that's what we're saying, x and y are what?
Symmetrical. No.
Equal to each other. Okay, x is equal to what? 0 and 0 here, so x is equal to what? Y, and this y is equal to this x. Okay, so if I look at the line y equals x then, let's see what that is. Okay, so I want you to think about the line y equals x. All right, so inverses are symmetrical about the line y equals x. All right, now remember, if I graph y equals x, and if I think about this in terms of a t-table, that means that the x and the y coordinates have to be what? Equal. So if x is 2, what's y? 2. If x is 3, what's y? 3. If x is -1, what's y? -1, and so on. Because that's what y equal x says. Y and x have to be equal to each other. So if I draw that line, y equals x, and I want you to think about where that line, which quadrants does that line go through, y equal x? Well,
1 and 3.
first of all, you do know that from what we just talked about, the x and y coordinates have to be the same, correct? So if x is 2, what's y?
2.
2. If x is 3, what's y?
3.
3. If x is 4, what's y?
4.
If x is -1, what's y? If x is -2, what's y? If x is 0, what's y? So y equal x goes through what two quadrants?
1 and 3.
1 and 3. And in fact, do you see that it actually goes to the middle of quadrant 1 and the middle of quadrant 3? Okay. So I'm going to draw that line, and I want you to notice, see where those two lines intersected? The line y equal x will also go through that point of intersection. So this is what happens. You get this. And so now remember, the line y equal x is a symmetry, so we're just going to go ahead and use a dotted line. Not a curved line, not a dots, but dashes. All right, something like that. So this is what line? Y equal x. All right. Now remember when we talked about symmetry with respect to the y-axis a while back, even function, we looked at distances. And we said those distances had to be the same. Same thing here. So if I look at this point, remember, if the point 2, 7 is on f of x, then what point better be on the inverse? 7, 2, and it is. All right, now I'm done with the graph. That's the graph. All right, so when you do that worksheet, that's what you're going to do. That worksheet I gave you yesterday. So you're gonna draw those two lines, and you should have already done that. I asked you to already have done that. The problem is that you didn't draw it far enough to where they intersected. So you're gonna do that. Then now you're gonna draw what line? Y equals x, the line of symmetry. So inverses are symmetrical by what line of symmetry? Y equals x always. Y equals x. All right? And so there's your graph, but what I want you to notice is this. If I look at 2, 7 and 7, 2, right here, and I look at these distances, the distance from the f of x to the line of symmetry, that distance right here, this distance better be the same as what? That distance, and it is, because watch. I don't want to draw it on the graph because I don't want you to think that what I'm drawing is part of the graph, and it's not. But I'm going to do this instead. So I want you to see this. That from here to here, I don't know if you can see it. Yeah, you can see it. From here to here, that's the same as from here to there. That's it? All right, the other point we had was -9, 0. So if -9, 0 is on f inverse, then what point better be on f? 0, -9, right here. Right here. 0, -9. And so if I look at that distance, so this distance here to the line of symmetry better be the same as that distance from the line of symmetry to that point, and it is. Okay? All right. So you're done. That's all you do there. All right. Now let's look at this problem. Let's look at this one. So number 2, let's suppose we had g of x equal x plus 1 divided by 4. X plus 1 divided by 4. And you want to find the inverse. And so what we're going to do is find the inverse. We're not going to graph it because you already know how to graph lines, and we just talked about the line of symmetry. So I'm just going to ask you to find the inverse. And we're going to find the inverse by inspection. So if I look at the function g of x, what operations is this function doing? I take the value of x and I do what to it? Add 1 and then do what? Divide by 4. Okay, that's the operation, the order of operation I would do this in. I would add 1, then I would divide by 4. The inverse does the opposite operations. Okay, so remember, what did I do last here? I divided by what? 4. So I'm going to do that first here. Okay, so what do you think the inverse will be? 4x minus 1. Very good. 4x minus 1. So you knew that the operations of the inverse better be multiplication and what? Subtraction. So you take the value x, you're going to multiply by 4 because you were dividing by what? 4. So you're going to multiply by 4, and then instead of adding 1, you're going to subtract 1. Okay, now in a little while we're going to do this algebraically, but that's the inverse. That's how you find the inverse. All right? Okay. Now, let's talk about the algebraic approach to finding the inverse. So let's suppose on my math lab you're going to have something that looks like this. F of x equal x cubed minus 4. X cubed minus 4. Now that's not linear. That's what kind of function? No, quadratic is x squared. That's cubic. X cubed, cubic. All right. That's a little bit more difficult by inspection to determine what the inverse is. So we're going to use the algebraic approach. So listen carefully to the algebraic approach. Okay, so step 1. Replace f of x. Now remember, with f of x means the same thing as what letter? Y. So replace f of x with y. So we get y equal x cubed minus 4. All right, and then a while ago, we talked about the line of symmetry y equals x. And we stated x becomes y and y becomes x. So that's where we use that idea here. So y becomes x and x becomes y. So step 2 is where you're going to replace x and y. You're going to interchange the variables. Let's just write it like this, interchange the variables. So then, instead of having y equals x cubed minus 4, you're going to have what?
X equals y cubed minus 4.
Yep. And then a couple more steps and you're done. The next step is to solve for y. All right, so how do you get y by itself? This is the first step. Add 4 to both sides. So I get x plus 4 equal y cubed. And then how to get y by itself? If right now I'm cubing y, how to get y by itself? Cube root. So I take the cube root of both sides. So the cube and the cube root undo each other. So I get y equals the cube root of x plus 4. And that is your inverse. So step 4 is now where you're going to replace y with f inverse of x. So that's your inverse. So f inverse of x equals blank. What's the blank? What goes in the blank? Cube root of x plus 4. Cube root of x plus 4. All right, so let's do a couple more. So we're going to do this algebraically. So let's suppose in number 4, you had g of x equal x to the 5th plus 2. All right, now this is a polynomial function. There's really no name for x to the 5th. Remember how there's a name for x squared, quadratic? There's a name for x cubed, cubic. Those are the only two special names. So if you see x to the 4th, there's no special name. If you see x to the 5th, there's no special name. We just say they're polynomial functions. So these are polynomial functions. All right, let me just tell you what a polynomial function is. A polynomial function, when we graph linear functions, that was considered a polynomial function. When we graph quadratic functions, that was considered a polynomial function. When we graph cubic functions, that was considered a polynomial function. Polynomial function has this form. You have g of x equal some number times x to the n power, where n is a whole number, plus some number times x to another n1 power, and so on. All right, so you have a bunch of terms. Basically, you have a bunch of terms, and each term has x raised to a whole number power. So you see right here, that's x raised to what power? 5. And then you could not only have one of those here, just one term, but then you have a constant at some point. So here's an example. F of x equal 3x to the 4th minus 2x squared plus 7. Is that a polynomial function? Is that a polynomial function? Yes. It has that form. X raised to the 4th power, 4 is a whole number. X to the 2nd power, 2 is a whole number, and then your constant. Now, you're not going to graph that in here. You're going to graph something like this next semester because you can take the derivative of this next semester. And then you can graph it using the derivative. All right. Okay. Now, finding the inverse of this, remember it has to be 1-to-1. Remember, a function has an inverse if it's what? 1-to-1. Well, if you were to graph this, by the way, if you were to graph this, you would notice that it's not 1-to-1. So you wouldn't be able to talk about an inverse. All right. But this one is going to be 1-to-1. So let's find the inverse. So what's step 1?
Swap out the g of x for y.
Yeah, so step 1, replace g of x with y. So I get y equal x to the 5th plus 2. Now you don't know what the graph of this looks like, but it is 1-to-1. So just take my word for it. What's step 2? Interchange the variables. So you're going to say x equal y to the 5th plus 2. Step 3, solve for y. So if I'm going to solve for y, what must I do first? Subtract 2. So I get y to the 5th equals x minus 2, right? And then finally, how to get y by itself? Take the 5th root of both sides. So the fifth root, because remember, the opposite of raising something to the fifth power is to take the fifth root. So the power 5 and the fifth root undo each other, so you get y equal the fifth root of x minus 2. And then step 4 is where you replace this y, because that's now your inverse, isn't it? That's now your inverse. So step 4 is just where you, instead of saying y, you say what?
G of negative.
No. G what? Inverse. He said g to negative. That I remember we talked about frowning on that word, right? Because it's not an exponent. And you actually do another one. Do it again. Yeah. All right. So your answer is going to be g inverse of x equal what?
5.
The fifth root.
Fifth root, x minus 2.
Okay. All right. Now let's do a linear function, because on one of your worksheets, although you can do it by inspection, on the worksheet that you're going to get, one of them is going to say, do it algebraically. All right. So if you do it by inspection and you don't follow the directions, you're going to be very upset with me. All right. So read the directions. So step number 5, rather. Number 5, h of x equals x plus 3 divided by, let's say, 7. I want you to find h inverse of x. Now you know what the answer is by inspection. What's the answer? 7x minus 3. All right. But I want you to do it algebraically. So if you don't do that work, you're not getting any points because you didn't follow directions. So what's step 1?
Swap out the h of x and y.
Okay, replace h of x with y. So you're just going to say y equals x plus 3 divided by 7, right? Then what you going to do next?
Swap the variable.
Yep, so then you're going to say x equal what?
Y plus 3 over 7.
All right, and then the next step is to do what? Get y by itself. So remember, let's clear the fractions. So I'll multiply both sides by what? 7, because the LCD is 7. So I'm going to clear the fractions. So I'm going to go ahead and rewrite this over. So you're going to say times 7 times 7. So 7x, the 7's here divide out. So you get 7x equal y plus 3. And then finally do what? Subtract 3. So I get y equal. What do I get? Y equal what? Minus 3. And so in the blank, though, you're going to say what? H inverse of x equal 7x minus 3. Okay? So that's the algebraic approach. Now, my math lab, there's a cubic one, so that's why I did a cubic one. On your test and on your final, they're going to be linear. So let me kind of give you an example of what you'll see on your test and on your final. All right, so let's look at this example. It's number 6. You're given 3 functions. F of x equal 9x minus 2. H of x equal x plus 2 divided by 9. G of x equal x minus 2 divided by 9. So you're given those 3 functions. Now, one of your final, the way for that kind of problem, they usually have it as multiple choice. So you make sure when you multiple choice, you can see the right or wrong. There'll be partial credit, so make sure you don't mess that up. All right, and the question will be this. The question will be, which 2 functions are inverses of each other? That's the question. Which 2 functions are inverses of each other. So you're going to basically what I want you to do is find the inverse of each one. Okay? Find the inverse of each one. All right, and that you can do by inspection, by the way. So right away you know what F inverse is. What's F inverse? X plus 2 divided by 9, right? Over here, you know what H inverse is. 9x minus 2. And over here, you know what G inverse is. 9x plus 2. All right? So, F inverse is the same as what? That one, right? And that came from which one? See how these right here are the same right here? All right, and this is totally different. So you're going to say which two of these functions are inverse of each other? F of x and g of x. So f of x and h of x are inverses of each other. Okay, because notice you get right here and right here. All right, and that's all you do. That's all you do. There's no work really to be done except what you just saw. Find inverse of each, and you're done. Just see which ones are alike. Now, to be honest with you guys, all you really could have done was, see this one right here? F of x? What's its inverse?
X plus 2 over 9.
Which is this one, right? So the inverse of this one is really this one, and you're done. You can stop. All right. Okay, so I think that takes care of. Oh no. Okay, one other thing before I can give you those worksheets. All right, let's look at this one, number 7. You're told F equals the set of ordered pairs. 3, 1, 2, negative 6, 7, 4, 5, negative 2, 8, 2. And then the question is this now. So there's your first of all, is this a function? Yeah. First of all, I wrote it in function notation. I'm telling you, this is what function F. So if I'm going to use function notation, then first of all, it better be what? Function. It is. For each x coordinate, there's only what? One y coordinate. Okay? So it is a function. Here's the next question, though. Here's the question you're gonna be asked. Is f a 1-to-1 function? Yes or no? Well, a 1-to-1 function says that what? For each y coordinate, there is one x coordinate, and you can use a mapping just like we did in a previous lesson on one of the previous tests. So basically I'm saying is this. You remember when we did a function and we used a mapping, we did x to y? Well, I want to know if it's 1-to-1, so I'm going to do y to what? X. So I'm going to put y first and then x. What's this y coordinate? 1. It gets mapped to what? 3. So far I'm good. For this y coordinate, there's only one x coordinate. What is it? 3. When x is negative 6, it gets mapped to what? 2. So far I'm good. So far it looks like it's a 1-to-1 function. If x is 4, it gets mapped to what? All right. If x is negative 2, it gets mapped to what? 5. If x is 2, it gets mapped to what? 8. So is f a one-to-one function?
Yes.
Yes. So then that means that f has a what?
Inverse.
An inverse. All right. So then it's going to say find the inverse. So if it is one-to-one, find the inverse. So since it is, so you're going to say yes here. So now find the inverse. Now you say you're going to write it though. You remember in the previous problem you just had, we would say g inverse of x, h inverse of x, f inverse of x. Remember that? But you don't see that here. You don't see an f of x. You just see a what? F. So you just say f inverse. That's all you do. So you're going to say this. You're going to say f inverse. So what's f inverse equal to? Now remember, these are ordered pairs, and think about what we talked about when we graphed these inverse functions and we looked at points. So what ordered pairs will be on the inverse?
1, 3.
1, 3. What's the next one?
-6, 2.
-6, 2. What's the next one?
4, 7.
4, 7. What's the next one?
-2, 5.
Okay. And then finally?
2, 8.
2, 8. All right, remember, when we did the graph a while ago, and even yesterday, if the point 5, 0 is on f of x, then what point's going to be the inverse?
0,
0, 5. So let's call this A right here, and let's call this B. Suppose that G equals this set of ordered pairs. Let's say 1, -2, 0, 4, -6, 5, 3, -2. First of all, it's a function, right? For each x coordinate, there's only what? One y coordinate. And you know it's a function because I called it what? I use the function notation g. I want to know, does this function have an inverse?
No.
Okay, why does it not have an inverse?
Because for the y coordinate -2.
Because it's not, just say, first of all, say it's not what?
Not 1 to 1.
It's not 1 to 1. So G does not have an inverse because it is not a 1-to-1 function. And you can tell that by using the mapping if you need to. Or you can just tell me right away what fails. When y is -2, there are how many x coordinates? 2. And the definition of 1-to-1 says that for each y, there's got to be what? 1x. So if you look at the mapping, and I'm going to go y to x, I'm going to go to the -2 because that's the one that fails. When x is -2, I get what x coordinate? 1. But I also get what x coordinate? 3. So notice when y is -2, you end up with how many x coordinates? 2. And the definition says you have to have just how many x coordinates? 1. All right? Okay, so that takes care of this section. All right, now, so you remember, this is on your test Monday.